Okay, this is the second video of graphing trig functions, and so we graph sine of x, and graphing cosine of x is going to be very similar. So let us start. Remember the x values, so we're graphing y equals cosine x. The x values are the angles that we're inputting, and the y values are the outputting ratio. And going around the unit circle where r is 1, we've got cosine would be the x-coordinate. So cosine is actually starting at its high point of 1. And then at pi over 2, it'll be, so looking up at right here, the x-coordinate is 0. And then at pi, looking at the x-coordinate, I'm at -1. And then at 3 pi over 2, I'm back at 0. And 2 pi, I'm back up at 1. And then let me extend my graph again here. Whoops. And then continuing in this positive angle correction or direction, or continuing around the circle, I've got 5 pi over 2, I'd be at 0. 3 pi, I'd be at -1, and then 7 pi over 2, sorry, I'm back at 0, and let's do some negative. Going clockwise, negative pi over 2, I'd be at 0, negative pi, I would be at -1, negative 3 pi over 2 is coterminal to pi over 2, so I'd be at 0, and negative 2 pi is coterminal to 0, so that brings me back to 1. So once again, we get this curve that looks very similar to sine, except for its high points or peaks and its low points or troughs occur at different values here. Although we can say that the two functions are just phase shifts or horizontal shifts of each other, which they are indeed. So the domain of cosine is all reals, and the range is just like sine, -1 to 1. And let's talk about where the peaks are occurring. So, before doing that, sorry, it's a periodic function, meaning it repeats after a certain interval of the domain. And so the period, just like sine, is 2 pi. Because if we start at 0 here, we're at our high point going down. And how often before that happens again? Well, it happens again after 2 pi. So the period is 2 pi. In terms of the peaks, well, here's a peak, and here's a peak, and here's a peak, and so on. So how often are the peaks occurring? Well, peaks are occurring every 0, I could say, as my starting point, plus 2k pi. So they're all 2 pi away from each other. Or I could just, it simply suffices to say that the peaks are every 2k pi, where k, of course, is an integer. Okay, in terms of the low points or the troughs, those are here. And I can use pi as a starting point here, because that's where the first positive one occurs. And I can say the troughs or the low points occur every pi plus 2k pi. Well, what type of function is cosine? Even, odd, or neither? Well, you'll quickly see that just cosine of x itself is a even function, and because it has that y-axis symmetry. And another reason is, by the definition, if I plug in a negative value, the output is the same as doing cosine of that positive angle. And a good way to see that, again, is let's draw an acute angle theta. Here would be theta. This would be negative theta. And cosine is positive in both quadrant 1 and quadrant 4. So it is true in this case that cosine of negative theta would be the same as cosine of theta. Okay, so now let's talk about tangent, which is going to be different than the other two. And the reason being is the definition itself. So tangent, so if we think about the unit circle again, let's think about the values tangent takes on. So tangent is y over x, and again, let me just put the points along the axes here. And so tangent of an angle is equal to y over x. So in terms of thinking about a triangle, well, the y and x can have any old relationship because the two legs, one doesn't have to be bigger than the other. One can be bigger than the other. They can be the same. And so it's different when we're in the quadrants than we were talking about cosine, where you can't have a triangle with the hypotenuse bigger than the legs. Well, and notice what happens with tangent. Like, so if I think about tangent of 0, well, tangent of 0 is 0. So tangent of 0 equals 0. But then the x-coordinate is 1, but the x-coordinate then gets smaller and smaller as we're going up towards pi over 2. And the legs are equal at 45. So tangent of 45, or pi over 4, equals 1. And then tangent of 0, tangent of pi over 2 becomes undefined because x is getting smaller and smaller relative to y to the point where x is getting towards 0. So let's see what that looks like graphically. All right, here. All right, so plotting here, we've got tangent of 0 is 0. Then let's plot the fact that tangent of pi over 4, we're at 1. And then at pi over 2, we're undefined, but we're exploding up towards infinity. So we're actually going to have an asymptote at pi over 2. And in order to kind of really get the shape of what's happening here, let's look at going in the negative direction. So again, tangent of 0 is 0. What is tangent of negative pi over 4? So if we're down here, well, at negative pi over 4, the y-coordinate is negative, but the x-coordinate is positive. So tangent of negative pi over 4 is going to be negative 1. But then at negative pi over 2, we're back, the x-coordinate is getting closer and closer to 0, and the y-coordinate is getting more negative. So let's draw what's happening there. So we just said we're going towards infinity when we're getting at pi over 2, but at negative pi over 2, we're going to be going towards negative infinity. So in fact, the graph takes on, whoa, that's not exactly how I wanted to draw it, but this type of look. And this, of course, I'm drawing out the x-axis a little bit to get you to see what's happening here. And then after pi over 2, well, let's extend it to see what's happening. So after pi over 2, if we look at 3 pi over, if we look at 3 pi over 4 and then look at pi, and then let's look at 5 pi over 4 and 3 pi over 2 to see what's happening. Well, 3 pi over 4, again, we're at negative 1 because the x-coordinate's negative, but the y-coordinate's positive. At pi, y over x is 0. At 5 pi over 4, tangent is positive because both x and y are positive. And then at 3 pi over 2, as we get close to there, that's where it's undefined. But it's undefined where both x and y are the same sign, both being negative, which will make it explode towards positive infinity. So again, we get this type of look here. Well, And if we continue in the negative direction, we'd see the same. But we have enough to get, so it would just keep on repeating itself, in other words. So again, we have a periodic function here. Actually, maybe I'll just keep it as this. But so what is the period here? Well, it repeats itself not every 2 pi. If I'm starting up at 0 and going up, well, this is showing me that when does that happen again? That happens again at pi, starting at 0 and going up. So the period, in fact, of this function is pi. And the domain is all reals except every pi over 2 plus, how far apart are the undefineds? Well, between pi over 2 and 3 pi over 2 is 2 pi over 2 or pi. So I would say undefined every pi over 2 plus k pi. And the range is all reals. And there are no peaks because the range is all reals. So the last thing about tangent is the fact that, like sine, it is an odd function. It's got origin symmetry, and tangent of negative theta equals negative tangent of theta. And you can convince yourself of that, of drawing the fact that if I do a first quadrant angle and take the tangent, and then I do negative that angle, that's in the fourth quadrant where tangent's negative, so tangent of theta, negative theta indeed will be negative tangent of theta.